This problem appeared in JEE in 2019, and in this problem, what we are going to do is we are going to find the value of m for which this line is a normal to the hyperbola. So this question can be solved easily if you remember the equation of the normal to the hyperbola, and that equation is actually given by y equals to mx plus minus m into a square plus b square upon square root of a square minus b square m square, wherein m is the slope of the normal. So this is the equation of the normal to the hyperbola, right? So if we remember this, then this question is easy. So in this case, we have to compare this equation with this equation. And what we can see is that my value here, which has to be not root 7, but rather it has to be actually 7 root 3. This question isn't right. This is actually 7 root 3. So if that being the case, right, that what will happen here is that this question would turn out to be that this should be equal to 7 root 3. So m into a square plus b square upon square root of a square minus b square m square should be equal to 7 root 3. Now, one thing is that what is a? A square is 24, b square is 18. So let's substitute those values. So we get a square is 24 plus 18, and then upon square root of a square, which is again 24, and b square is 18, m square, which is equal to 7 root 3. So this will become m into, and then this will become 42 upon square root of 24 minus 18m square, and that is actually equal to 7 root 3. So 7 6 is 42. So now this will become 6m equals to root 3 into the square root of what, 24 minus 18m square. Now, of course, we have to square it on square this equation on both sides, and this will become 36m square, which is going to be equal to 3 times 24 minus 18m square, and this will become 36m square. This will become 72, and then this will become 54m square. You bring m square this side, this will become 54 plus 36, which will be 90 m square. So 90 m square will be 72. And then m square is going to be equal to 72 by 90. So not a better thumb in the pay, and then r this. So what you get is m as plus minus 2 upon root 5. So one of the values will be 2 upon root 5, and this is what will be your answer. So this is when you remember the formula for the normal. What if you don't remember? If you're like me who doesn't remember those kind of formula. So what I do generally, if I somehow find these questions, so I'll start working with the equation of the tangent, which is much easier to remember. So this is actually here, we are starting with the second method, which is little longish, but this is your go-to method if you forget your equation of normal. And it's easy to remember equation of tangent. So in this case, this is x square upon 24 minus y square upon 18 is actually equal to 1. So equation of tangent is much easier to remember because this could be written simply as x1 upon 24 minus y1 upon 18 equals to 1. And then you could write this as y1 upon 18 is actually x1 upon 24 minus 1. And then you could write this as y equals to 18 upon 24 into x1 by m1 into x minus 18 by y1. So why did I do it is because I wanted to get the slope in terms of this, right? Now this is the slope of the tangent. So the slope of the normal will be reciprocal of it with a minus sign. So this will be 3 by 4, right? So my slope of the normal, call it as m. So m would be actually equal to minus 4y1 upon 3x1. And what I would do is I will just go ahead and then write this equation, which is y minus y1. This is the equation of normal, equals to m times x minus x1 minus 4y upon 3x1 and x minus x1. So this would become y. So y minus y1, and that would become equal to minus 4y1 upon 3x1 times x plus this will become 4 by 3y1. And then if I send y1 to the other side, this will become y equals to minus 4y1 upon 3x1 x plus 7 by 3. This y1 will go on this side, so this will become 7 by 3 y1. Now I'll compare this equation with whatever is given to me, which is y equals to mx and plus 7 root 3. Now we know this is what we have called m, so this is what is my 7 root 3. So this is 7 by 3 y1 is going to be equal to 7 root 3, or y1 is going to be equal to 3 root 3. Now how do I get x1? Because I want to get x1 as well to get this, right? Because x1, y1 will lie on the hyperbola. So this will be x1 square upon 24, right? X1 square upon 24 minus y1 square upon 18 is going to be equal to 1. This will become x1 square upon 21 minus y1 square, which is 3 is 9, 3 is 27 upon 18 equals to 1. So this is the Sutra. So we'll get x1 square as 1 plus 3 by 2, because I've sent 3 by 2 on the other side, and then multiplied by 24. So this will become 2 plus 3, which is 5 by 2 into 24. So x1 is actually plus minus the square root of 60. Now I substituted here to get value of m, which is minus 4 by 3, and y1 was 3 root 3, while my x1 is square root of 60, which could be written as 2 times root 5 times root 3, right? And then there could be a plus or minus sign both, right? Now this root 3 would cancel, 2 will cancel, 3 will cancel. So what I get in the end is plus minus 2 upon root 5. Right, so one of the values of m would be plus 2 upon root 5. And this is another way of doing it. And this is the more generic way, because all the time you would be able to, all the time you'll be able to find the equation of the tangent in this manner, whether your x y square comes this side, x square comes that side, and so on and so forth. I mean, even for the other way, you would be still able to do this. So this is a kind of a foolproof method, little longer, but I think you can try this approach as well. All right. So yeah, thank you for watching this video. If you have any question, please do ask me in the comment section below, and I'll be really happy to answer your queries. Thanks once again. Have a good day.